Yeah, this morning, for the next 30 minutes, I will discuss a concrete overlays in Texas. So we will discuss the concrete pavement in general in Texas. Then we will discuss the history of the concrete overlays. And then we will look at some good and not so good performance of the concrete overlays in Texas. And right now there's a research project going on, and we will discuss what we are doing and the final summary. So this is the lane mileage of concrete pavement in Texas over the last, say, from 1994. So PMIS has a data from 1993. So this blue line shows the lane mileage of CRCP, and this red one shows the CPCD. As you can see, there has been steady increase in CRCP mileage. So right now we have over 12,000 lane miles. Now that's the most CRCP, actually concrete pavement mileage in the nation. But what we can see over here is that as of 1993, at the time we had around 4,000 lane miles of CRCP and around 300 lane miles of CPCD. So as of now, what we can say is that at least we have 4,000 lane miles of CRCP that are at least, 22 years old, and some of them are very old. So say philosophically, not philosophically, but up to this point, we spend lots of research money and effort to improve the pavement designs for new construction. And if you look at the specifications, we also have item 360, again for new concrete pavement, but we don't have any standard spec items for, say, concrete overlays. We don't have those yet. So we, again, we spend lots of effort to improve the new construction. But now, since we already have this many lane miles, I think it's time to really pay attention to figure out what to do with all these aging concrete pavement. So I think this is and the concrete overlay provides a really good, cost-effective, pretty good solution to the managing of the all the infrastructure we have. Right now, this is from the CP Tech Center from Iowa State. This is the general guidelines, pretty much on what kind of concrete overlay type we have to select. But the problem is that this is their criteria is the existing pavement condition before treatment. So they provide the options, say, for example, if the concrete pavement is in good condition, yeah, we can have a banded concrete overlay. If it's a fair or poor condition, then yeah, we can put unbanded overlay. But the problem is what constitutes good condition and what constitutes fair condition. So as a design, as a textile engineer, it will be difficult to really get some good information on, okay, you know what? In my opinion, this pavement is in fair condition, so we have to use unbanded overlay, that kind of thing. So they provided this guidance in terms of, say, qualitative type information. So we needed some information on, say, more quantitative type information. So we are working on it right now. So what we are doing is that we are trying to evaluate the pavement condition in terms of, say, deflections. So if the deflection is this much, then yeah, then you can put banded overlay. If the deflection is more than this, then yeah, you have to use an unbanded overlay. That's what we are working on right now. So over the years, since 1983, TxDOT actually built a number of concrete overlays. So in general, we have 4 groups of overlay structures. One is CPCD over CPCD, then CRCP over CRCP, and the thin concrete pavement. Since we don't have when the concrete is very thin, we don't have reinforcement, so we just say thin PCP on CRCP, and also we have one project on where we put the CRCP overlay on CPCD. In Texas, the overlay thickness varies from 2 inches to 12 inches. And we also put the interlayer or no interlayer. That means bonded or unbonded. That's what the big picture of what we have in Texas. So we have actually more overlay projects than this one, but this is a, I want to discuss briefly each project. So the first one we built in Texas is the one on Loop 610 South in Houston. So that was built in 1983. So that's just east of I-45. So that is what, 33 years old as of today, right? So that's so under lots of traffic. So the performance has been, to me, very good. Then we had 4-inch BCO on Loop 610 North between Ella and I-45, built in 1986. Actually, the performance has been really excellent. But they had to reconstruct the Loop 610 North and US 290 area, so they had to replace the whole thing over there in 2013 or 14. So they provided almost 30 years good performance, excellent performance. Then in 1988, Dallas District built 11-inch CPCD on 10-inch CPCD. The performance has been satisfactory. And also in 1990, Dallas District, again, they put the 10-inch CPCD on 10-inch CPCD. That's unbonded, an excellent performance. And in 1994, Bowman District put the 12-inch CPCD on 10-inch CPCD. In 1996, El Paso District placed the 6.5-inch or 7-inch CRCP on CRCP on I-10. And we had some problems at the beginning, but when we evaluated 2 years ago, the performance has been still great. So we are learning a lot about what's going on. So now I think we are in a, I think we can really now develop specifications and standards for overlays because we learned a lot. And in 1998, Houston District placed a 3-inch BCO on 8-inch CRCP on State Highway 146 in Baytown. We had lots of problems. So it's very interesting that in 1983, we put 2 to 3-inch BCO, but over 30 years, it was performing very well, whereas in 1998, we put 3-inch, then it failed actually miserably. So again, we are getting good information regarding what worked and what didn't. And in 2002, actually Doug Beer is here. He was the project engineer. So he put the 4-inch CRCP over 8-inch on US 281. The performance so far has been excellent. Then 2010, on US 75, we put 7-inch CRCP on 10-inch CPCD. We will discuss in more detail later on. And 2012, again in Wichita Falls, they placed 4-inch CRCP over 8-inch CRCP. Then we had some problems. So we are getting some good information as to what happened. So among those, we'll just take a look at these 7 projects in more detail. This is a Loop 610 South, again, completed in 1983. And this is the picture. We took a picture last year, and it looks pretty great after more than 30 years, even though there are some failures at the joint area and one repair over here. Other than that, it's been performing great. And I-35 in Denton, so they placed 11-inch CPCD overlay on 10-inch CPCD. So this is a 1960 1960, typical section. That's what they did, 10-inch CPCD. Then they put 11-inch CPCD. Then interlayer was 2-inch asphalt. So overall, the performance, the condition is pretty great. So we did the evaluation this year. The only problem is there are some, what do you call it? Andrew, is that? I don't know, it's very rare in Texas, but yeah, we have some problems. So actually, this is the same joint, as you can see, same joint. We looked at this one in 2012, March. And this year, February, so 4 years. Actually, they still remain the same, except that they had to put some more asphalt over here. So we took some concrete cores to see what's going on over here. It looks like, again, it's all speculation, but it looks like they saw cut maybe too early, that there was some micro damage in the concrete. Looks that way. So we did deflection testing. So this blue line shows the average deflection. So it's less than 1 mil. That is great. I mean, that's the lowest deflections we've seen in concrete pavement in Texas. I mean, we've done lots of FW testing in Texas. So this is LT at the joints. They are around between 70 and 80, so that's great too. So now this is the slab thickness versus average deflection statewide. So we went all around the state, then we measured the deflections with CRCP with the different thicknesses. So 0.8 mils, that is very, very low. Okay? That's actually more than, smaller than even the deflections for 15-inch concrete pavement. So from a structural standpoint, this section is excellent. In other words, I'm not so sure whether really we had to put 10-inch unbonded concrete overlay. That seems to be a little bit over-designed. So we are working on improving design procedure as well. Now this one, I-35 East in Waxahachie. Again, that was built in 1990. So you got 10/10 with 1.5 inch ACP in between. Also, this is a part of the LTPP database. Actually, this section is in a great condition for the last, 26 years. Really great. Again, we did the FWD. The deflections are also pretty small too, which is an indication of, again, a little bit over-designed, but still pretty good. But the only problem we saw was that this is the joint, and there was some crack going on over here, so we took a core right there and to find out what happened over here. As you can see over here, this is the joint in the old concrete pavement. So they saw cut around 7 inches away from old joint. So we shouldn't do that, right? So in the new specifications, we are working on the specifications in the research project. We will have a tolerance for joint location, say within plus minus 1 inch, right? Otherwise, we will have this kind of delamination over here, this kind of cracking problems. Other than that, this section is in a perfect condition. Now, the section on State Highway 146 in Baytown, 8-inch CRCP and the 3-inch BCO. Yeah, we have problems. But most of the overlay projects in Texas have been a part of research projects, but this one was not. So we don't really have that good information regarding, say, what was the condition of the existing pavement and what kind of materials they used and what kind of construction sequence they followed for overlay. We don't have that kind of information. I was just asked to evaluate what's going on, so I was involved, and the primary mechanism of the distress was all the delamination over here. So since then, TxDOT Houston District placed the asphalt overlay. Now, US 281 in Wichita Falls in 2002, actually June 2002, 4-inch bonded overlay. So they used a skid brader for the prep for the existing pavement surface. This is a close-up view of the texture after skid brader. So they placed concrete at night. At that time, there was some controversy going on whether we have to keep the existing surface wet or dry. We chose to keep the surface SSD condition. So looks like that was a good decision. And also at the time, there was some discussions regarding whether we can place steel this way. Some people at the time expressed some concerns about maybe the longitudinal steel is too close to the surface existing. But it looks like when we ran the bond testing, it looks like it's still a good thing. And so in general, it's in an excellent condition, except that we have a distress at the construction joint over here. So we did the FW testing along this one, and also mirror testing. So this mirror testing shows what's going on inside the concrete. So at this location, so 4-inch, that's the inner face, we have delamination. Not only that, this is around 10 inches. That means there's a delamination going on in the existing concrete pavement as well. So this pavement, the old pavement was not in a great condition. Then we have this kind of problems. So we moved, then we did that mirror testing, and once you go over here, then we don't have a delamination. This is still in the old concrete pavement. So that's the only distress we have, except for the some problems at the bridge interfaces, locations. So we will again improve the specifications. Now this is the CRCP overlay on CPCD. So we did that in 2010. What happened was that the CPCD on this US 75 was in a very poor condition. I mean, they had lots of problems. Noel was he was the project engineer over here. So what we did was, okay, let's select the section that is in the poorest condition to see whether this 7-inch CRCP type system works. So I know, from a researcher standpoint, we wanna see some failures. Then we learn something so that we can improve something. So I know this graph is a little bit crowded, but this red one is the deflections in the CPCD before we placed overlay. So these are the deflections in terms of mils. As you can see, some deflections were more than 40 mils, 30 mils. So the slabs were actually rocking over there, right? I mean, really bad condition. So we were trying to figure out what should be the criteria for the bonded overlay. So what we found out is that if the deflections are more than, say, 20 mils, so these black dots, that's where we have problems. And however, we found out that from joint 0 to all the way to 120, the distresses in overlay actually increased this way. So these are the maps of the CPCD condition before we put overlay. And what happened is that when we have these cracks in the CPCD, we have to repair those, okay, before we put overlay, bonded overlay. Otherwise, we will have this kind of distresses. That's what we learned. So now we have joint 110. Over here, we have a problem. Joint 111, this area, they already repaired it. Now, US 287 in Bowie, that's the original pavement was built in 1972. Then the overlay was done in 2012. So actually, this pavement provided a 40-year service. I'm sure that the design life was 20 years. And but later on, we have some problems. So they put the asphalt overlay over there. So this is the condition of the existing CRCP. Again, 40 years old. So there are some areas with lots of problems. And so we did the FWD testing. Again, as you remember, this is the 8-inch CRCP, so we expect around 3.5 mils of deflections. But as you can see, in some areas, we have even more than 30 mils of deflections. Very weak area here. So what we are doing right now is to get some correlation between the deflections in the existing CRCP and the condition of the overlays to get some threshold value of the deflections for the overlays. And then we did some bonding testing as well. So bonding was pretty okay, 186 PSI, but we still have problems. So these kind of problems. So we are getting some good correlation between the existing condition of the CRCP, deflections versus what happened in the overlaid section. So right now we have a research project, 6910. So we are analyzing all this data to understand what works and what doesn't. What happened is that Texas DOT doesn't quit, right? Say, for example, Illinois DOT, they tried some overlays, only 2 or 3 projects. They saw some problems that they stopped. They are not doing it at all. The CRCP, the same thing. Many states in the past, in 1950s and 60s, they tried the CRCP. Then they didn't like all those cracks. They stopped, like South Carolina, even California, and all those. But Texas never did, right? We kept working on it. Actually, the credit goes to the late Dr. McCullough. And so now Texas knows how to build the CRCP. And the same thing over here, we have a wealth of information on overlays, what works, what doesn't. So we hope that we will be able to come up with a guidelines regarding, not in terms of qualitative assessment, but quantitative, right? Like a TPAD, FWD, then you can tell, you know what, look, we can do this, or we should do this, okay, that kind of thing. And also, so we are trying to develop the threshold values for deflections for PCO unbounded overlay. And also, we are working on improving the overlay design procedures. Right now, we are using AASHTO. So we are really getting into how that procedure was developed, and there's no good technical background, really. I mean, the reporter says that they are not so sure where that concept came from. That's what they are saying. The bottom line is that the current AASHTO UBCO procedure is very conservative, okay? Very conservative. It gives very small credit to the support condition for the existing pavement. So we are improving that design procedure. As discussed, we don't have a standard construction specifications as well. So we are actually developing. Right now we have special specifications, but we are improving the special specifications, and we hope that by 2014, TxDOT will have a standard specifications for overlays. So in summary, TxDOT has many miles of PCC pavement that already exceeded, actually, or are approaching the 30-year design lives. And concrete overlays could provide a cost-effective rehab method. The performance of the concrete overlays in Texas has been quite satisfactory with some exceptions. Again, we learn a lot from those exceptions. When we fail, we learn something, right? So that's a good thing. And currently, efforts are underway to further improve PCC overlay design and construction material specifications. That's all I have.